everyone, my name is Sofia bin Abdurrahman, your first presenter for this presentation. Today, we will explore the fascinating field of chromatology and its vital role in forensic science. Chromatology is the scientific study of color that is crucial in helping investigators analyze and interpret evidence from the crime scene. In forensic science, chromatology allows scientists to distinguish and identify chemical compounds based on their distinct color properties. This capability is essential for uncovering hidden details within complex mixtures found at the crime scene. The samples analyzed using chromatology in forensic science are diverse. They include drugs, explosives, inks, toxins, and biological samples. Each of these requires precise and detailed analysis to provide meaningful insight. Through chromatography techniques, forensic experts can trace the origin of substance, determine the composition of unknown samples, and establish connection between evidence and suspects. This makes chromatology a powerful tool in criminal investigations. There is multiple chromatography techniques that could be used in forensic science, but in this presentation, we are going to focus on just one chromatography technique, which is high-performance liquid chromatography, that is also commonly known as HPLC. HPLC works by separating different compounds in a mixture based on their chemical properties such as size, polarity, or affinity for the stationary phase. HPLC is crucial for a range of forensic applications. One primary use is detecting drugs in bodily fluids such as blood and urine, which is essential for toxicology reports. Additionally, HPLC is used to analyze trace evidence like fibers and explosive residues found at crime scenes. Another important application of HPLC in forensic science is confirming the authenticity of documents through ink analysis. By separating and identifying the chemical components of inks, forensic experts can determine if the document is genuine or has been altered. The accuracy and sensitivity of HPLC makes it an essential tool in forensic science. It provides reliable scientific evidence that is crucial for solving crimes and supporting legal cases.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zuri Nur Shamimi binti Zahid Abu Yahya. I want to highlight that no matter how good the HPLC techniques works in mixture analysis, it also has its pros and cons. If we go forward to the advantages of HPLC, it shows that HPLC provides high selectivity, it allowing for the precise separation and identification of individuals' components within complex mixtures. This is critical in various applications to get accurate identification, for example, drug detection and quantification. Next is the sensitivity. HPLC also provide high sensitivity, which can make it more capable in detecting and analyzing trace amounts of compounds. It's particularly useful in situations requiring the analysis of low concentration substances. The most important thing is HPLC offers speed and efficiency analysis. The technique enables rapid analysis that can give benefit for time management in high throughput applications like clinical diagnostic and quality control labs. Last but not least, automation additionally increases the productivity of HPLC. Since HPLC depends on the machine, there is a little chance that a human error will occur. Regardless of all the advantages, HPLC also comes with some disadvantages. I can say that the obvious disadvantages of HPLC is the cost. You know what? For a small lab that's just starting, the total cost can come close to $30,000, which is 141,390 ringgit. We need to spend too much money for HPLC systems and their maintenance. The equipment of HPLC itself is expensive, such as organic solvent and columns. Additionally, method development in HPLC can be complicated. It is a challenging task for beginners since they lack expertise and experience in troubleshooting issues. This complexity can affect time taken and resources needed. At the same time, it will increase the cost. Next, we back to the sensitivity. It is true that HPLC is highly sensitive for many compounds, but it may exhibit low sensitivity for certain substances, so it might be unsuitable for some specific analytical application.
Hi, my name is Ayamira Husni bintu Madaini. Now I will present to you the methodology of HPLC. The evidence analytical method known as high performance liquid chromatography (HPLC) is used to separate, identify and quantify certain components in mixture. Okay, for the sample setup, the analyte is dissolved in a solvent that is solute with the mobile phase to form the sample. After that, an injector is used to injecting the sample into the HPLC system. Okay, next, the most important part of HPLC is the column. It is packed with tiny porous particles, usually measuring anywhere from 3 to 5 microns in diameter. And alumina or silica or any other hydrophobic material is usually the stationary phase. Okay, let's move on to the detection. The individual molecules that elute from the column are found using the detector. Ultraviolet visible, absorbent detectors and refractive index detector are common types of detectors. Okay, for the last one is data analysis. Software is used for analyzing the data in order to calculate each component's peak area, peak height and the retention of duration. The amount of time it takes to a component to elute from the column is known as the retention time.
Hi everyone, I'm Shasha and I will be presenting to you about the application of HPL chromatography in forensics. First are the drug detection and quantification. HPLC is a highly precise method for identifying and quantifying the quantities of pharmaceutical and their metabolites in biological sample. It is crucial in intents of drug overdose, driving while intoxicated, and drug-related offense. Second, poison analysis. HPLC enables the detection of toxins, particularly to intrinsic mixture, facilitating investigation into possible poisoning or hazardous exposures. Third are the post-mortem toxicology. HPLC plays a crucial role in determining the cause of death by detecting and measuring hazardous chemicals that may contribute to the fatality. And lastly will be the method development and research. HPLC is usually used in research to generate novel methodologies for detecting emergency illicit substance or to improve existing procedures. Now let's talk about one of the famous murder cases that used HPLC as the research method, which are the Tylenol murder. Back in September and October of 1982, 7 people in the Chicago area died after ingesting extra-strength Tylenol capsule that had been laced with potassium cyanide. This led to a nationwide panic and a massive recall of Tylenol products. In the investigation, HPLC were used by the forensics to identify the presence and concentration of cyanide in the contaminated Tylenol capsules. Forensic scientists use HPLC to separate and identify the cyanide in the Tylenol products. The technique allowed them to detect even smallest amount of poison, confirming that it was present in the lethal doses. High-performing liquid chromatography or HPLC is often used in forensic investigation to analyze virus substance. One notable case is the 1982 Chicago Tylenol murderers.
And that brings us to the end of our journey through the basics of high performance liquid chromatography or HPLC. Okay, for the conclusion, in modern forensic science, HPLC is a pillar. HPLC has revolutionized the way we analyze complex mixture, detect substance, and uncover evidence. From identifying unknown compounds to quantifying drugs, toxins, and explosive, HPLC provides forensic scientists with the detailed, reliable data needed to solve cases and deliver justice. HPLC is more than just a technique. It's a cornerstone of forensic science that ensures the integrity and accuracy of our work. Through its use, we uphold the standard of justice and contribute to a safer world. Okay, thank you for joining us on this journey through the basics of high-performance liquid chromatography in forensic science. Stay curious, stay informed, and continue to appreciate the science behind the scenes. Thank you, bye!